So let's start with day one, AP multiple choice questions without a calculator. I went ahead and gave you the problem sets because they do have concepts in them that you need to know. So I figured this would be another great review sheet for you to look at because there are some major concepts in here along with the math that are important. Let's look at the first problem. A 23-gram sample of a compound contains 12 grams of carbon, 3 grams of hydrogen, and 8 grams of oxygen. Which of the following is the empirical formula of the compound? Remember that empirical formula is a ratio of moles of each element in that formula. So basically, remember the steps. I'm going to make a list of all the chemical quantities I have. Convert that to moles. Divide by the smallest. If those are whole integers, I stop. If they're not, I multiply by a whole number integer to get them to be whole numbers. And you start at 2, then you go to 3, and so on and so on. Right? Those are our steps. So the first thing I want to do is I want to make my laundry list of chemical quantities. I've got 12 grams of carbon, 3 grams of hydrogen, and 8 grams of oxygen. I want to convert this to moles, so I'm going to divide by the atomic mass. And I'm going to take this right off the formula sheet. Okay. Grams divided by the atomic mass is going to give me moles. So I get, in this case, 1, 3, and 0.5. So let me transfer that over here. 1, 3, and 0.5. All right, remember, we have to divide by the smallest. That is always the one that everyone forgets. We don't want to forget that. We're going to divide by our smallest one, and we get 2, 6, and 1. Those are whole number integers. Carbon is 2, hydrogen is 6, and oxygen is 1. That is answer E. All right, the next problem is a redox reaction. It gives you the full balanced equation, and it says 2 trials are run using excess water. That means that the chemical quantity of water is not going to be significant in this problem. In the first trial, I've got these conditions. In the second trial, I've got these chemical quantities. Each reacts completely, and they make the same amount of SO2. Which of the following identifies 1, the limiting reactant, and 2, the heat released, or Q? So this is going to be two things you're going to have to find. Now remember, when we find limiting reactant, we've got to convert all of these chemical quantities to moles. And once we figure out how many moles of each we have, we know that we're making the same amount of this, but that will fall out anyway. We're just going to focus on this ratio. I have to make this work, a 2-to-1 ratio of Na2O2 and sulfur. So let's do trial 1 first. Trial 1 is here. So for Na2O2, I have 7.8 grams divided by the molar mass. That is going to give me my moles, and that is 0.1 moles. Now, however you want to do this, if you want to remember long division, I put my decimal up here, I divide, it goes 1 time, and I get 0.1 mole. You can move your decimal whatever you think you need to do, but you should be able to very easily go to 0.1 mole. Now for sulfur, it's basically the same thing. I'm going to do sulfur on this side. Sulfur is 3.2 divided by 32. So again, that's 0.1 mole. So I've got in trial 1, 0.1 of that and 0.1 of that. In trial 2, I've got the same amount, notice, of this one. But for sulfur, I have 6.4 grams this time, or double the amount, which means that this is going to be equal to 0.2 moles. 0.2. All right, now, when I look at this, I have to have twice as much of this as I do this. So if this reaction proceeds, I'm really only going to use that many moles of sulfur for this one. And I'm only going to use 0.05 mole of this one. So both of these are in excess. So that means that NaO2 has to be my limiting reagent. Remember, even though there's a 2 here and a 1 here, if I convert everything to moles, this is a 2-to-1 ratio. This is in excess. So that leaves me with either C or D. Okay. Now, let's go to the next part. So it says on here that I need to calculate Q. So I'm going to start this over here. Let's put a line here. And if you remember, delta H is equal to the negative of Q over mole reaction. Okay? Negative Q over mole reaction. Now, I've got this. What is my mole reaction? Well, it's said on here that it makes the same amount of product. Well, how much product is that? So if I have 0.1 mole of this and 0.1 mole of this, then I'm going to make 0.05 mole of SO2. And that is going to be my mole reaction because I have a 1 in my coefficient there. So the number of moles of product I get is 0.05. That is my mole reaction. So what I'm going to do is I'm going to substitute negative 610 is equal to a negative Q over 0.05. That means that Q is equal to about 30.5. You could have just kind of had that be 600, right? 600 times 5, move your decimal point over, you get this. So you have to be able to do this math, 610 times 0.05, easily. One way you can do this, I teach this to my APE students if you're really worried about all the decimals. Convert everything to scientific notation. This would be 6.1 times 10 to the second times 5.0 times 10 to the negative 2. When you multiply two scientific notations, you multiply these together, which is about 30.5, and you add your exponents, which makes it 10 to the first, or 1, which gives me 30.1. So that means my answer is there.